Hello and welcome back to SUPERMESH. So this is example 2. If you are new here, please consider subscribing to PA Academy, where we share a lot of engineering videos from engineering drawing, technical drawing, electrical and electronics engineering topics, mathematics topics. So if you are here to subscribe, please subscribe to this channel. Alright, so this is example 2. We've looked at one other examples and two other videos under this concept. So the links is in the description. The links to those videos, you find them in the description of this video. Now let's look at this example 2. We are having this circuit and we are asked to find the current in the 3 meshes. Now we have one mesh here. This is 1, 2, 3. And the question did not even tell us anything. Maybe it's mesh analysis or anything. But we are going to be using the concept of super mesh to solve this. And why are we using super mesh? Because as you can see, there is a current source between these two meshes. Between the mesh we're having here and this mesh, there's a current source here, 3 amp current source. So that's to tell us that this is what we can use super mesh to do this. All right, so let's pick our current direction. So let me call this I1. So let me call this I1, and then let me take this to be I2, clockwise direction, and then I3. All right, so based on the direction of the current, so let's pick our polarities for all the resistors we are having here. So for this 10 ohm resistor, so this is going to be plus and minus because of this I1. This is going to be plus and minus. So because of I2, this is going to be plus, minus. This will be plus and minus. And because of this I3, for this 5 ohm, this will be plus, minus, plus, minus, plus and minus. Alright, so having done that, so the next thing we have to do is to write our equation of what? Of current source. So equation of current source. So equation of current source. So let me draw it where we are having the current source itself. So this is it. So it's alright. The other color seems to alright. So this is it, and we have this is given to be 3 amperes. So we have two currents flowing through it. We have I3 and I2. So I3 is like this, so that means it's going in this direction. While I2 is like this, so it's in this direction. Alright, and like I said, let me indicate that this is I3 and this is I2. So like I said, if you have to write the equation of the current source, whichever one that is in the same direction with the current source will come first. So this I2 is in the same direction with the 3 amp. So we are going to be having I2 minus I3 equals to what? 3 amperes. So that's the equation that, and we take that to be our equation 1. So we'll take that to be our equation 1. Okay. Alright, before we continue, let me just, so that it will look different from the other question, let's make this, instead of 3, let's make it 5. 5. Since we've not gone far, it won't affect much. So let's take it to be 5 amperes instead of 3. Alright, so let's continue. So we are having I2 minus I3 equals to 5 amperes. Alright, sorry, let's just leave it the way it is, 3 amperes, 3 amperes, and 3 amperes. So we've gotten the equation of the current source. So the next thing for us to do is to draw our mesh circuit, our super mesh rather. So in drawing our super mesh, this is the super mesh, that's this circuit itself from here to here, like this. So we are going to be drawing it, don't forget, without the current source. Also, now if you look at this question, you see that there's a little difference between this and the one we looked at earlier. I said we are going to be, in drawing the super mesh circuit, we are not going to be adding the current source. But if you look at this particular example, we are having a resistor on the same line where we are having the current source. So what do you think will happen here? Are we going to draw it? Okay, let me just, so are we going to be having something like this? Alright, so I haven't drawn this. So what happens to the 3 ohm resistor we're having here? Since we are not going to be including the current source, don't forget, like I explained in the other examples we looked at and at the beginning, in drawing the super mesh circuit, we are not going to be including the current source itself under super mesh. But what happened to this? What do you think is going to happen? Are we going to omit it, or we are going to add it? Alright, so whenever you come across this, you are going to be omitting it with whatever element you are having on that particular branch. Exactly. So we are having a current source here alongside a resistor, so we are not going to be including it when we are drawing a super mesh circuit. So every other thing will remain the same. So this is our 10 ohms, this is our 2 ohms, 1 ohms, and then 5 ohms. And don't forget, it's the same direction. So now let's put in the polarities based on the current that is flowing through it. So here is plus, minus, due to current I1, and then here we have it to be plus, minus, due to current I2. So let's do this. In this direction we have it to be plus, minus. So I didn't indicate it, this is plus and minus, due to the current I2, and then here we have it to be plus and minus due to current I3. I hope you are getting what I'm doing. So we also have this to be plus and minus upward direction due to current I3. So why this is downward direction? So you can see I3 is coming down, is in downward direction for this 1 ohm resistor, while for this 5 ohm resistor is going upward. Alright, so here we are having plus or minus in downward direction due to current I1. So having done this, now let's write the equation for this particular circuit. So you can start from any of the nodes. So let's just start from so where do we start from? So let's just start from here, and then we go around the circuit. Alright, so from here, this is from negative to positive due to current I1. So you are going to be having 5I1. From positive to negative due to I3, so that's going to be minus 5I3. So we are done with this. Now let's go here from negative to positive due to I1. Don't forget we are dealing with the 10 ohm resistor. So from negative to positive, that's going to be plus 10I1. From positive to negative is due to I2, so that's going to be minus 10I2. So we continue there, we'll come here. So this, since there is only one current that is flowing through this 2 ohm resistor, as you can see, that's I2. So from positive to negative, that's going to be minus 2, and then the current there is I2. So we come here, from positive to negative, that's going to be minus 1 I3 equals to 0. So now let's simplify this. So if you should simplify this, I always rearrange it such that I'm going to be having I1, I2, and I3 equals to 0. So it makes it easier for us when we want to compare it with other equations. So we are having 5I1, 10I1. So that's going to give us 15I1. So let's see, what are we having for I2? We are having minus 10I2 and minus 2I2. So that's going to give us minus 12. Minus 12I2. Let's see for I3. So we are having minus 5I3 and minus 1I3. That's going to give us minus 6I3 equals to 0. Okay, so yeah, that's correct. And this is going to be our equation 2. Don't forget, this is our equation 1 here. Alright, so let's go ahead and solve for our equation 3. So let me just, since we are working with only red pen, let me just demarcate. So let's solve for our equation 3. In solving our equation 3, we are going to be solving this mesh. So this is what we are going to be solving. This is what we are going to be solving. Alright, so since we have it to be current I1, so let's just call it mesh 1. So that will be apply KVL to mesh 1. So if you have to apply KVL, so let's just take it from this node and then we go around this particular mesh. So from here, this is the first element we are coming across, which is a voltage source, 50. So from negative to positive, so that will be plus 50. So we can just have it as 50. So when we get here, and then here. So from positive to negative, that's going to be minus 10I1. That's due to I1. Also, we have from negative to positive due to I2. So that's going to be plus 10I2. So when we come down, we are done with this element. Let's look at this other elements, which is a resistor. From positive to negative, that's going to be minus negative 5I1. So that's due to current I1. So we have positive to negative due to the current I3. So that's going to be plus 5I3 equals to 0. Okay, so now let's simplify this. So where we are having I1, so we have minus 10 and minus 5. That will give us minus 15. Minus 15 I1. What about that of I2? We're only having one I2 here. This is 0. So this is 0. So for I2, 10. Okay, we're having only 10. So that will be plus 10 I2. And then for I3, we're having only 5. So that will be plus 5 I3 equals to. So if this 50 comes to the other side of equals to sign, it becomes minus 50. And this becomes our equation 3. So now we've gotten our equation 1. This is our equation 1. This is our equation 1. This is our equation 2. And this is our equation 3. So for us to get, don't forget the question said that we should find the current in the 3 meshes. That is I1, I2, and I3. That's what the question is asking us to look for. So for us to get the values of those I1, I2, and I3, so just like we did earlier in the previous example, so you're going to be solving the 3 equations. You are going to solve them simultaneously. So you can go ahead and pick them and solve them simultaneously. Whichever method you want to use to solve them simultaneously, substitution, elimination, or you can use your calculator, which is the one I prefer. So let me write out those values. For this, we don't have I1, so I can just have it as 0 I1 because it's still 0. But because I want to use calculator, so I have to just put some values there. Then plus I2, plus this I2 is the same as plus 1 I2, so I just have it as plus 1 I2 minus 1 I3 equals to 3. That's for equation 1. So equation 2, we are having 15 I1 minus 12 I2 minus 6 I3 equals to 0. For equation 3, this is equation 3, we are having minus 15 I1 plus 10 I2 plus 5 I3 equals to minus 50. So just the same thing I did in example 2, I'll be using my calculator again to get the values. So my calculator is already in that mode. So once I put in those values, A1, I'm having it to be 0. Once I press 0, I hope you can see it. Press equals to, then 1 minus 1, and then 3. So the next one is 15 minus 12. I press equals to sign, and then minus 6. I press equals to. It asks for D2, which is this, which is 0. So the next one is minus 15. Okay, sorry, I made a mistake there. I pressed 15, so I can just use the replay button. So that's minus 15. So if you want me to do a video with on this calculator showing you some shortcuts and some things, just let me know in the description, and then in the comment section rather, and then I'll definitely do videos. So I've put in the values and I press my equals to sign, and I've been able to get the value. For my I1, it's giving me 20, so I hope you can see it. So that's 20. X is showing that X equals to 20. That X means I1, and it's showing that my Y equals to 17.666. So that is our I2 is 17.666, and then our I3 is 14.666. So let me write that down. So that means if you solve this, so even if you solve it manually using any method, you still get the same answer. So I1 is equals to 20 amperes. So don't forget your unit. I2 equals to 17.667 amperes, and then I3 I hope you can still see this. Okay, so I3 is 14.667 amperes. So you can see that super mesh is a very simple concept. It's not difficult at all, and just using super mesh you've been able to solve this. Now let me also add this, like I said in the previous video, some questions, no questions will not tell you if a question is super mesh. They will only tell you using mesh analysis. So they won't tell you if it's a super mesh. But once you're asked to solve a question using mesh analysis and you come across the diagram and you see that there's a current source in between two meshes, just know that it's super mesh. No questions, the questions will hardly tell you that this question is super mesh. So they expect you to know when it is super mesh. I hope that is clear. Some will just refer it as mesh. They see it as mesh. Some don't separate it as super mesh or mesh. They see everything as mesh. But just know that when there's a current source between this is what you do. You write out the equation of the current source. You have your super mesh circuit. You solve it. Then you solve the other mesh. Depending on how many mesh you have in the circuit, you can have as much as 4, 5, depending on how the circuit is. So that's it for this example 2. In the example 3, we are going to be looking at something different and unique. So make sure you don't miss it. So if you have any question on this video, please leave it in the comment section. If you find value, please give it a thumbs up, and subscribe if you are yet to subscribe. Please click on that subscribe button to subscribe to this channel. Alright, so thank you very much, and I'll see you all in example 3.